Alright, so Assalamualaikum and very good day. My name is Muhammad Faiz Amiruddin bin Abdullah. My matrix number is CE200135, and as usual, I am going to present about my ideas and also my final year project, which is design of horizontal transfer mechanism between wheelchair and car for disabled. So currently I am under my lecturer supervision, who is Professor Madya IR Dr. T. Kian Sek, and we have a few collaborators, and also I want to acknowledge this project to Professor Dr. Sam Tung Hai, who is from Faculty of Business and Communications (FBC) from INTI International University that located at Nilai, Negeri Sembilan, and we have our industrial collaborator, which is Mathematic Manufacturing Sdn Bhd, which located at Senggarang, Johor, Malaysia. So without wasting any time, let us go to our objective. So there is three main objectives that we need to reach, which is analyze or identify the need for transfer mechanism or device for getting in and out of a vehicle or car. And then we need to develop a mechatronic system that allows wheelchair user getting in and out of the car effortlessly, from wheelchair to a car. And then for the last one is we need to evaluate the performance of the proposed mechatronic system, including its cost effectiveness in terms of installation, maintenance, and etc. Right, so for the scope of work, there is 5 main elements that we need to focus on, and at the same time, these 5 elements shows that there is project limitations that we need to be considered of. So for the first one is development of the wheelchair. The wheelchair users can be transferred from their wheelchair into the car using the horizontal transfer mechanism. And the second one is the transfer process is only enabled for loads under 100 kilograms, and a motor driver and a swivel are used to move the horizontal transfer mechanism. And then we need to test the outcomes for the specification of horizontal transfer mechanism. And the last one is the front passenger seat will be the primary focus of this project testing, which will use the most used car like the Program AV, both generations, old generations and also the new generations. Alright, so for the next part, methodology, I set the standard for my project's principle, and we have 3 principles that we need to take care of. So for the first one, I need to make sure the wheelchair user's initial position, and then the user position during the transfer process, and the last one, I need to make sure that the transfer process is done. So I need to make sure that the patient has been transferred from the wheelchair to the car seat or vice versa. And then transitioning to the new idea or concept. So previously I used a seesaw concept, which are quite good in transferring patients, but after a few field implementations and also experiments based on 3 candidates, I observed that there is some issues that cannot be considered successful. And then after a reflect through the observations, I noticed that the 3 candidates give the same feedbacks, which is their crotch and also their legs are in between the we call it the trolley backbone, and obviously it is not comfortable at all. So I decided to move from this concept into the new concept, which what we call it lifting up and down concept. So the reason that I use this concept is to make sure that this concept providing a better solutions for the previous issues, which is to lift and transfer the patients without any risk of falling, and giving or providing the best hospitality to patients and also their caregiver. Alright, so we go to the next part where I decided to install several components into the transfer mechanism, which is planetary geared DC motor, screw mechanism, and also seal lead acid battery as our source. And then we notice that there is two sections that I installed, which is IoT monitoring and also motor control. So IoT monitoring basically is for caregiver to monitor the patients when lifting and before transferring. And then after that, for the second section, which is motor control, is to control the speed of the motor, which is planetary geared DC motor. And if you notice, there is two types of microcontroller that we use, which is ESP32 module and also Arduino Uno. Alright, so the reason that we use two types of microcontroller is some of the microcontrollers are not capable enough to to use its capability at high voltage, such as ESP32 module, which are not capable to provide more than 3.3 volt. So I decided to use Arduino Uno, since Arduino Uno can provide more than 5 volt for the DC motor and also its DC motor driver. Right, after that I decided to set a standard for the design element, which we have 5 important design element that we need to consider, which is detachable for the first design element, and then the transfer mechanism must be easy to use and manageable by normal adult, and then of course the transfer mechanism must be portable, since this mechanism we need to use from wheelchair to car seat and also vice versa. So we need to make sure that this transfer mechanism is not heavy, and also the most important one is the transfer mechanism must be safe to be used. Right, so to reach our objective and also our design element, I decided to design a C-shaped base which have adjustable width. So the wider that it can be, the more secure that the patients being lifted. And then I install an up-down lifting mechanism, which is motorized jack screw, to ease the caregiver to lift the patients without using their energy. And then I need to make sure that both caregiver and also patients are not at risk of falling and also have a long-term injury. Alright, so for the flow chart, we started by turning on our power supply, and then we need to make sure that our user is on the wheelchair. And is it the position of the user balanced? If not, we need to adjust the user positions. And if the user positions balanced, we proceed to control button to control our planetary DC gate motor, which has only two features, up and down. And then after that, after we have confirmed the height of the patients after being lifted is not touching, their bum is not touching the seat of the wheelchair, we can transfer the patients to the seat. And then we need to make sure that if the user have reached the car seat, if not, we can adjust the range or the level of the patients when hanging. So if the height of the patients when hanging is too low, we can adjust back by control button to control or to push the up button to patients to be lifted up. And then after that, if the the patients have safely landed or reached the car seat, the process will be terminated. Right, so we go to the next part, which is result and analysis. There will be two results and also there will be two analysis. So for the first result, feasible studies, I have made a survey that target to both caregiver and also wheelchair user. So after 2 weeks of the survey, I observed that I have 50 respondents that took the survey from the studies. So basically, the studies or the survey has two sections, which is feedback from wheelchair user and caregiver, and then the importance of designing transfer mechanism. So for the first section, feedback from wheelchair user and caregiver. For the first question that I asked is their income classifications. So majority of them are from M40 and also B40, which hold the same percentage of 36%. And then I asked if they need the assistive device or not. So majority of them, 61%, said yes to the assistive device or transfer mechanism. And then for the third question, I asked how much cost do they spend for the assistive device for the past months. So majority of them spends from 500 as their minimum cost to more than 1,000 ringgit. And then after that, I proceed to the second section, which is the importance of designing transfer mechanism. And I asked the reason on why they go out weekly, and majority of them state that they go out or use transport for medical appointments, and then follow up by 17.9% for social activities or event. And then I asked how frequent for both caregiver and also wheelchair user to go out. So majority of them said 3 to 5 times a week. And then for the third question that have been asked is if they worry or not about not using assistive device. And this question is related to the next one, which is what is the main reason of them worrying about not using assistive device. So the majority of them say they are worried about not using assistive device, and the main reason is why they are worried is that 54.5% will feel physical discomfort or pain for both caregiver and also wheelchair user. They stated that they feel physical discomfort or pain from being lifted by not using assistive device, and they have long-term injury, such as caregiver. They have long-term injury on their pain, such as back pain, and also the risk of falling that stated by wheelchair user. Alright, so for the second result, for the field implementation, they have two parts, which is hardware design, implementation, and also assembly. So as I stated before on the previous slide, I have installed adjustable width for the secure of patients when they are being lifted. After that, I put backrest on the tips of the armbar, so that there is certain patients that are not strong enough to lift or to sit on their back, and then they are tend to lying and cause themselves to be fall on their back. So I decided to put this and it is aligned with our design element. So after that, I install U-bracket for planetary gate DC motor to attach with the core, and these features can be detachable and also easy to use. So it is aligned with our design element. And then after that, I installed two type of bracket, and also clip, which is seat belt buckle clip for more secured lifting, and also U-type loop bracket in case they have bedridden patients. And then this is the diagram of two sections, which is on the left we have IoT monitoring, and then on our right we have motor control. Alright, so for the second result, we have weight measurement for parts. So the reason that we measure every part's weight is to make sure that the transfer mechanism is detachable and not really heavy when they want to attach back. And then after a measure uh, after every parts measurement, we observe that the total weight for our transfer mechanism is 24.1. Since our limit weight is 25 kilo, the final weight is less than 25 kilo. So it making that the solution is portable and easy to use for patients as well as caregivers. And then we go to the next analysis, which is weighing test. So the reason that we use the reason that we conduct this test is to accomplish our third objective, which is to design or to evaluate to evaluate the performance of this assistive device and align with our scope of works, not more than 100 kilo loads that are being tested. And then this is the time taken for the transfer mechanism to be at full retract with no loads, and this is the time taken for the transfer mechanism to make a full retractions with 100 kilo loads. So after that, we use this result as our reference to test on 3 person with different weight and height class. So basically there are 3 person. We call it as person A, person B, person C. So 3 of them have 3 different class of weight and also height. So for the first person, person A, his height is 171 cm and have 80.2 kg, and the time taken for the person to be fully lifted is 15.88%. And then for the second person, person B, his height is 183 cm and his weight is around 65.7 kg, and the time taken for the person B to be fully lifted is 19.52, slightly longer than the person A. And then for the last person, with height of 169 cm and 58.3 kg of weight, the person C only took 12.96 seconds to be lifted. So as we can observe from this result, person A are more heavier than person B but lifted in a less time. So it showcased that the apparatus versatility across different body types and weights. So to conclude, this test or the transfer mechanism demonstrate that the device has adapt and meet the criteria for the needs of people with varying physical attributes. And then for the second time evaluations, I have divided into 2 sections, from wheelchair to the car seat and also from car seat to the wheelchair. So I will teach my demo video for this result. Okay, so for the last one, for future work and also recommendations, implementing IoT makes it easier to monitor and control remotely and provides carers or caregiver with real-time data. And by lifting height and speed customization options, it will meet the needs of each user, and extensive training materials guarantee safe operations. And then, of course, we need to work together with medical experts to yield insights for specialist features. And for the last one, we need to be constant in implementing hardware and software updates, guarantees that the device will always be flexible. Alright, so last but not least, I want to express my sincere gratitude to Professor Dr. Sam Tung Hai, who is a professor at Faculty of Business and Communications (FBC) from INTI International University, which are located in Inline, Negeri Sembilan, for his invaluable support and also contribution throughout the making of this project. So thank you, Prof. Right, so that's all from me. I hope this presentation gives a big exposure to our small community, and I hope this presentation will reach our attention for the sake of our disabled community. So thank you very much. Have a good day. Bye.